All right. So welcome everybody. Is the sound okay with the microphone? Okay, that's cool. Thank you very much. So thank you for being here with me today. I'm very happy to be here. Thanks for the opportunity. Just a quick information before we start. This is going to be a relatively technical session, right? All the code that we're going to talk about is going to be in C#. Now, if you're not a .NET developer, don't leave the room, because it's going to be relatively easy, right? I'm not going to use anything fancy from the language, mostly class, functions, and generics. You know, the basics. And the first question you might ask right now is, well, who's this guy? Assuming that would work. It does. So my name is Guillaume. I am a .NET developer advocate for Vonages, and as it was mentioned before, I come from France, just for you. So this is where you can find me online. So GitHub, everything I do is open source, basically. LinkedIn, I'm always happy to connect. And there is also another GitHub account, which is a free organization that we made with a friend to share things about extreme programming, TDD, and other things. So we have a free TDD workshop. We have a free knowledge base. Everything is free and open source. So go there, take it. What else can we say about it? I'm also the host and organizer of the Software Craft Luxembourg meetup. And we are still operating online. So if you want to join, you are more than welcome. We also have a YouTube channel. Everything is recorded. Feel free to join. And on the side, I'm still also a coach and mentor for people in teams. So yeah. So exceptions. What is there to say about exceptions? So quick show of hands. Can you raise your hand if you had to deal with exceptions at least once in your career before? 100%, all the time. How predictable. Okay, all right. Well, first off, what are exceptions for? Well, they are here to deal with unexpected and exceptional situations. I'm fine with that. That's the definition. So you know that when you get an exception somewhere popping up, something bad happened, technically, on paper. Now the thing is, today I don't necessarily want to talk about those situations, and I want to focus on a situation that is neither unexpected nor exceptional, and it's validation, because it's a situation where we see a lot of exceptions. So let's assume we have a service that allows you to retrieve a user from the database, a data store, whatever you want. So you have that function that takes an email and returns a user, and you have one statement to actually fetch that user. Just on top of that, you have an if statement that verifies that the email is not null or empty. And if it is, it throws an exception. That's a guard clause. So I'm fine with that. Guard clauses are awesome, by the way. It's a way to make sure that the input, what gets inside your function, matches your requirement before you start using it. So that's great. So we end up with something very simple, 5 lines of code. It's hard to complain. Yeah, well, try me. So you see, in the guard clause, we have something, we throw an exception. Remember the previous slides? Unexpected, exceptional. That's not unexpected. I don't know if there are any TDD practitioners in the room, but if there are any, we agree that if you were to implement this function, you would start by a test that asserts that if you call find user with null, it throws an exception. Yeah, it's not unexpected. So maybe not the right place to use it. So even though everything there is fairly simple, it's very much flawed. And mainly because even though it's very simple to write, it's not that simple to use, actually. I'm going to show it to you. So when you want to use it, you have this, service.findUser of an email, and you get something. What do you get? You can't be sure. You may receive a user, you may receive null, you may get an exception. If so, of which type? You don't know and you can't be sure. The problem there is, well, we have a transparency problem, because the method signature is kind of lying to you. When you look at the method signature, it's find user of string return to user. There is no mention of exception and no mention of nullability. So that's a problem when you want to use it. And the thing is, that transparency problem has a more important consequence, which is, yay, defensive programming, try catch everywhere. We love it, don't we? Yeah, that's a big problem. It's very intrusive, and so in this way, it forces you to have that try-catch block there, because if you don't and you throw an exception, your application crashes and it's not something you want to have. So it's like throwing the hot potato to someone else, because, hey, it's not my problem, I'm just throwing something and you deal with it. But beware the consequences. Second problem, in the catch block, we rely on the global exception type. You probably heard before that this is bad, because it usually means that you don't know what to expect. It's exactly our scenario. We don't know what to expect, we have to rely on that global exception type, and that's not good, okay? And finally, we have some logic for dealing with a potentially missing user, which is fine. So we arrive with a convoluted solution just to deal with a very simple scenario. Right. So I want you to look at this. I want you to look at this as two sides of the same coin. One is writing the code, which is like super easy, 5 lines of code, yeah, everybody happy. And then you have using the code, which is quite a different experience, right? So exceptions have become the de facto standard when we want to deal with validation, because it's super easy, it's not new, it's how I learned at school, it's how I saw my first experience in engineering. It's the way it is. But today I don't want to show you how to throw exceptions. I want to show you how to avoid them by introducing something a little bit different that will focus more on transparency and predictability. Okay? And I have to apologize because we're going to talk about monads. So don't leave. Okay? It's going to be fine. Now, I could go the easy route and just show you the definition of what a monad is, and I can come back in 30 minutes. But this is exactly not what we're going to do. This is a problem. Monads are a construct that comes from the functional paradigm, okay? And everything in that paradigm has to be complex, for whatever reason. So what I will try today is show you how it is, what it is, how to use it, why you should probably use it, and try to stay away from everything that is close to math, science, a little bit, category theory, anything like that. Because I'm not a genius, I'm a developer just like you. If I can do it, you can. Okay? And so before we dive into what it is, we have to go through a middle step, and we need to talk about what a functor is. So I don't know if there are any hardcore functional developers in the room. If you're there, be gentle, because I'm going to simplify things, I'm going to make shortcuts, because I want other people to join the party, okay? So, chill. So we can see a functor as a wrapper around a value, like a box, to which you can map a function, to apply a function to a value. Makes no sense, that's normal, stay with me. And then we have a monad, which is a functor plus. Okay? That's all you need to know by now. We'll come back to that later. And so to illustrate that, I'm going to use a very simple example that comes from quantum mechanics. I said simple. Schrödinger's cat. You probably heard about that before. At least you've seen someone with a t-shirt saying that the cat is dead and alive at the same time, which is that, but not really. So Erwin Schrödinger, physicist, Nobel Prize winner, a little bit smarter than me. What he says is basically that you have a box and you have a cat, okay? Now the thing is, it's not just your ordinary box from Amazon or DHL, because the box is trapped. And the box contains two things. One is a radioactive element, and the other one is a trap that can release deadly poison at any time without you being aware of it. And so what Erwin is basically saying is, as soon as you close the box, the only way to tell if the cat is dead or alive is to open the box again. What a genius. Actually, what Erwin is trying to explain there is the principle of quantum superposition. In quantum mechanics, until you can observe the state of something, you have to assume it can be of an infinity of different states. And you have to make a tangible observation to quantify the state at this time to make sure that, okay, this is the state of X or Y. So the cat is not dead and alive. It's dead or alive in the box. You don't know. And in the meantime, you can still use the box. You can carry the box around. You can throw it in the air. You can put it in your car. Don't do it. But you can. So what I did was to implement a box in C#. Not a lot of code there. Just starting from the bottom, we have two static factory methods to create a box with either nothing in it or a cat. And you see that at the top, we have a field to hold the cat value. And the cat is a struct. So it's a value type. And by default, it is not nullable. So this is why we have a question mark there. So basically, an instance of the cat means the cat is alive. Null means the cat is dead. And the box has 3 capabilities. The first one is shake. So you shake the box. Oh, it's going to be fun. I like cats, don't get me wrong. It's an example. So if the cat is alive, we call meow on the cat, which logs meow in the console. That's very creative, I know. There is a question mark over there, which is a null propagation operator. It means that if cat is null, we don't do anything. And if cat is not null, we call meow on that cat instance. And then we return the box. Then you can shake too hard, which does the same. You shake, but you return the box with a dead cat inside because you just killed the cat. Happens. And finally, you can open the box. And this is where you can observe the state of the cat. Because the field is private, there is no other way to see in which state the cat is. So when you use that thing, if you have the box and you call shake, 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 you see in the console, you see meow, 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 which works well. And if you call shake, shake too hard and shake, you have meow only twice because on the shake too hard, you kill the cat, and on the second shake, well, a dead cat doesn't meow, so makes sense. Now that's fun. We have a box with a cat that can be either dead or alive, but it's fun, but I won't go far with it. It doesn't mean we have to throw it all away, though. Because right now, the box contains a cat, but it could contain literally anything else. Any object. A person, a date time, an integer, whatever. The problem we have right now is the 2 states that we have are not necessarily meaningful. Yeah? What is that? It's because of the cat, you think? Okay, so we have... That's new, that's a ghost. Okay. So yeah, the 2 states we have are not necessarily meaningful enough. So we could switch them to something like either I don't have a value and I have a value, for example. That would work. Let's try. So this is how the box looks like now, which is very similar. We still have the 2 factory methods at the bottom. Constructors are private. The state is private. And we still have open box. Nothing changed. The only thing is there's no point shaking anymore. I mean, what would be the consequence of shaking at that time? Makes no sense. So instead of doing shake, shake too hard, I replaced them with something else called map. And so map is a function that takes a function as a parameter. Ooh, scary. Actually, not so much. So you're going to pass to map a function that takes the type of the value inside the box, and maybe another type as a result. And if we are in a sum state, we're going to call that function on a value and return the result into a new box. And if we don't have anything, well, we don't do anything. A dead cat doesn't meow. Kind of the same thing. Here's an example. So I have 3 in a box. When I call lambda value lambda value plus 1, I open the box, there is 2 inside, 3 becomes 4, and I put 4 into a new box, and I return the new box. Fairly easy. You see? Create a box, 3 inside, and you call map value lambda value plus 1. Value lambda value plus 1 is a function. It's a lambda expression. So value is the name of the parameter, and what's at the right of the lambda is what you're going to return. It's essentially an increment method. So if you used LINQ before, which I hope you all did, this is basically a select, except that you're not on a collection. You're transforming the value that is inside the box over and over. So if I call sum of 3, I increment 3 times and I open the box, I should get 6. And in the same way, if I have nothing, I open the box, well, nothing goes in, nothing goes out. I have nothing, I get nothing. So you have nothing, you increment 3 times. That's still nothing. Quite straightforward. Well, celebration time, we just made a functor. It's a very complex term for something that is not so difficult. Now, if you paid attention, you probably noticed that the box that we have right now is very limited, in a sense that the state will never change. If you have sum, and you called map, you will always end up in a sum state, and if you're in a non-state, and you called map, you will remain in a non-state. Could be cool if we have something to, switch things over. Well, here comes bind. And bind is very similar to map with 1 or 2 key differences, and especially on the function that you give it. Because as you can see, map takes one result, one type, and transform it into another type, and then you wrap the value into a box. Bind takes a function that takes a value up as a parameter, but returns a box directly that can be in a different state. So when you return something, with map, you put the result in the box and you return the new box, while with bind, you return the new thing. Here's an example. I want to get half of a value, okay? Especially for an integer, otherwise it wouldn't work. But I want to see if I can divide the value by 2, I return a box with a sum state and the result. And if I can't divide by 2, I get none. Okay? So same than before. I have a box with 4, I call half, I get a box of 2. Not 2, a box of 2. Like this. So sum of 8, half becomes 4, half becomes 2, and half becomes 1, technically. Yeah. And if you have like 3, and you call half on it, take 3, call half, can't divide by 2, and you return an empty box. So in that case, you have sum of 4, call half, you get 2, you call half, you get 1, you call half, you get none. There was a change of state on the third bind. So I don't know if you paid attention, but since the beginning that we've been playing with that box, we never interacted directly with the value. We always played with the box directly, with map, with bind, and there isn't any branching in the code to verify whether the value, we have a value or not. It's always the same flow. The only thing that changes is the input, and therefore the output. Well, spoiler, this is not something I invented alone in a cave. It has a name, and it's called railway-oriented programming. This is a visual representation of it. So you have to assume that your code is composed of multiple tracks, and one of them is considered a success, and the others are failure. Now, the thing is, you have to assume that you remain on the green track, the success one, if you want things to happen. And so as soon as something fails, you end up on the red one until the end of the flow. So you can do the same thing with standard if statement. That would work. It's just a different approach. So we had 8, you call half, you get 4, you map it to 5 with increment, you get half, you can't, you get none, and you end up on the red track. It's basically what we've done before. And so, congrats, we made a monad. Remember? A functor that you can change. Now, I could stop there after half an hour and say goodbye and go back home. But I want to still go up for some things. So, for example, the big problem I have right now with the box as it is today is we rely on null when we open the box. So if we are in a non-state, we always get null. But I hate nulls. Everybody hates nulls. It's called the billion-dollar mistake for a reason. So how do we do? Because how do you represent the absence of a value if you can't use null? You can't. But what you can do instead is offer a fallback scenario, a fallback value. So I want to introduce you to match. Match doesn't take one, but it takes two functions as parameters. Getting crazier by the minute. Actually, not so much. The reason we have two is because we have two states. We give to match one function per state, and we're going to execute the one based on the state we're in. So this is going to replace openbox as a way to extract a value from our box. Here's an example. I have sum of 3. I increment 3 times, I get 6, and I call half on 6, I get 3. So when I call match here, I have a box of 3. I offer to match 2 behaviors. We're going to use the one in the sum, which is assigned to the sum part, because we're in the sum state, and it will return the value is sum. Similarly, if I'm in with sum 4, increment 3 times, you get 7, half would return none, and then you will get the value is none, because you're in a non state. So number null, me happy. Okay? Now, the more we progress and the more bad things I see, because I don't know if you see the way I see, but I see a lot of functions. And some of them are actually duplicated. Increment appear there 3 times, and so, yeah. What I want to do at this stage is to extract everything. So depending on which IDE you're in, if you're on Writer, for example, you just do Control-RM, extract method. It takes 2 seconds to do that, and you may end up with this. Now, why would you want to do this in particular? Well, it's very interesting and very important to bring intent in your code. What do you want to do? And the thing is, what you do is more important than how you do it. How you do it is in implementation details. It's noise. When you arrive on a function for the first time and you see dozens of lines of code of processing things, it's too much to understand what you're going through. While if you use just method names, you can express something more important than the code, which leads to declarative writing. When you achieve this, your code suddenly reads like a story. You have a list of a sequence of operations. So sum of 3, increment, increment, increment half, and then do whatever you want. You can show this to a junior developer or a non-technical person. Assuming they know what map is, bind is, and match is, they can understand your code. So if you want to dig deeper on that, I really recommend you to look at Code That Fits in Your Head by Mark Seaman, because he has something on that based on a study on the human brain, which is very interesting. So this is something I would recommend you to do very often. Last thing on that, this is the final iteration of our box. Okay. I know the code is small, just for one slide. This is the F# equivalent. So F# is a functional language in the .NET framework. And now you achieve something that allows you to be very close. The reason I think it's cool is because if you want to learn a functional language, you will never get a better bridge than this. Because now you just have to put your code on diet, and you're basically writing F# code. Scott Blashin said many times that even if you don't use functional language on a daily basis, just learning it will make you a better dev. And I fully agree. I felt that. So in summary, if I have to go back to what a monad is without the atrocious definition we had before, just a box, right? Can have multiple states, you can chain it, and you can play with it without knowing the state of the value inside. That's kind of it. Now I know what you're going to say. We've seen examples with arithmetic operations, right? Incrementing, division, that's nice for presentation, but I work on a complex application in the financial industry. It wouldn't work here. Yeah, I'm going to show you. The first thing that we need to clear out of the bat is we had to implement the box from top to bottom. You don't have to do that, because you have libraries to do it. And you have that in every language. Here in .NET, the most famous one is Language X. By far my favorite external library ever. One downside is it's not very well documented and it's very overwhelming. So there will be blood involved, but I had to learn. But there are others, and if you're in Java, you have Vaver, and if you are in TypeScript, you have FPTS. So you have that for a lot of languages. And so on the right, I just put there a couple of examples of existing monads, because the one we did with the first one, the option maybe, where the two states are none and some, but you have plenty of those. You have try, where you can have either an exception or a success. You have a result, which is either failure or success, or the either, which gives you full control on what the two states are. And I want to go back on the first example I showed you with the find user service, that one. What would change if I would replace that exception by something else, by a monad? Well, here it is. The first thing I want you to pay attention to is the method signature, the first line. The return type is not user anymore. It's either an error or a user. So there you achieved something we called referential transparency. Okay, that is crazy important. Someone who will use that function will know it can return an error in some cases. And otherwise, we kept the guard clause because guard clauses are awesome. The only thing is we do return now an error instead. Actually, a box of state left, because by definition on either the left is the error side, and we give it a validation failed error. And then we retrieve the user from the data store, and if it's null, we also return a left, which is going to be another error of type missing user. So, like, we got 3 additional lines of code compared to before, because we try to focus more on objects, so yeah, that's fine. On the caller's perspective, it's quite different though. So on the first line you see you have service.findUser with an email, and you get an either. And so then you can call match, that we've seen before. So for the success pass, I call user found, like we used to. And on the error side, I'm using pattern matching, and then depending on the error type, I will do different things. Because actually, if you're building an API, you might not want to return the same status code, whether the validation failed, because that would be a 403, and if the user is missing, that would be a 404. So you might want to deal with those differently. So back to the reality. What do I use Monads for? So I need to give you some context about what I do, why I work on that. So at Vonage, what we do is communication APIs and network APIs. So we're exposing APIs to do a lot of stuff. And APIs mean anybody can just make an HTTP request, call that API, and do with everything. The problem is that involves a lot of boilerplate code that nobody wants to write nor maintain. So what we do, we put tooling in the middle. So we offer SDKs to people, SDKs in Java and Python and other things, and how convenient in .NET. But this is what I'm working on. Trying to make HTTP calls easy and deal with all the level lifting in the meantime. So, where do I start? The first thing I take into account in my workflow is the data. For example, someone wants to initiate a two-factor authentication process with our APIs. I get a few things like a phone number and blah, blah, blah. That's fine. And so the first step for me is parsing. Parsing is basically transforming a less structured input into a more structured output. So I'm verifying that all the data I get is valid, matches my requirement with guard clauses, like if you want. And so I already have there a separation of tracks, because these can fail. It's validation. In that case, I have a different state. Then I transform my request into a proper HTTP request, which can fail as well, because this is where we, for example, generate a token based on the credentials. Then I send the request with the client, and I get a result, which is either, again, success status code, failure status code, whatever, and buckle up. Then I need to deserialize, and this is where all hell breaks loose. Because actually, whether it's a success or a failure, I need to deserialize both, and both can fail. So now is going to be the quite heavy part of the talk, because I can't spend as much time as I would on every single snippet. So I'm going to guide you through it so that you can see I'm not lying. And anyway, everything is open source, so you can go on GitHub and verify and call me a liar if you want. That's fine. I'm happy to talk about it. So the first thing we do is I have a verify code request for a verify code workflow, and I rely on builders for it. So if you have questions on that, call me later. And so I just fill there the mandatory stuff, so the request ID, a code, and I create my request. I get a result of verify code request. We didn't see that one before. Simple reason is I didn't use language-X. I was a bit sad for that. I implemented my own set of monads. So it's a custom one, but it basically exposes 2 states, success, failure, and that's it. Then I transform it into an HTTP request message with something being done on the HTTP request itself. And I send the request. Now, I kind of lied on the previous slide, because actually when you send an HTTP request to something, it will never fail. The HTTP will always be a success. You have to define manually by yourself whether it's a success or not based on the status code. And this is what I do at the bottom. This is where you have a ternary operator inside a bind. Yeah, I mean, had to be done. And finally, deserialization, because again, whether I get a proper response or an error from our APIs, I need to be able to deserialize both of them, create proper objects, and those can fail as well. So here we are. So now when you look at the code from the caller's perspective, this is what you get. You create a request, you build it, then you pass it to our custom client, you get a result, and you decide what happens when it worked, what happened when it didn't. So now if you remember about what I mentioned before about the 2 sides of a coin, writing versus using, this is quite different in terms of usage. And so I do consider the developer experience to be much better this way, because you have less things to deal with. Now, one question I got a lot is, what do I do if I don't want to use your goddamn monads? Yeah, it's a fair question. So I did implement something else, which is called get unsafe on my monads. The idea is to force an unwrap of the value in the box. But if the box is not in the right state, what we do is I throw an exception with the right type for you. So you can still use exceptions with this if you don't want to deal with match to extract something for whatever reason, which is fine. It's me trying to make everybody happy the best I can. But then you have to deal with that. I do prefer the pattern matching we had before, but it's a free country. So now is kind of time to reflect on everything we said. And should you get rid of all exception ever? I'd say maybe, maybe not. We need to have a more nuanced point of view there. Because just like good old Sanoth over there, exceptions are inevitable. They're everywhere. Okay. They are probably in the code you write, but they are definitely in the code that you don't write. Dependencies that you use, framework that you use. So what do you do? And actually, even Thanos got defeated by exception. So what can you do about it? So I'm going to use an architecture example from the port and adapter architecture. Is there anyone who's aware of that? Port and adapters? Okay, a few hands. Not bad. First thing, can we agree this is an hexagon? I was too lazy to make one, so I made a circle, okay? But in my reality, this is an hexagon, okay? So this is the domain in that architecture. The business rule, everything that is business related, business logic, what makes the value of your product, right? That's the center of it. In order to interact with the outside, you have what we call ports. And on those ports, we are going to plug adapters. And so you have 2 types of adapters. You have the driving adapters, which are the starting points of your application, which can be an API, a service, a front end, a console app, whatever, you name it. And on the right, you're going to have driven adapters. these are the dependencies of your system, what your system needs to work. It can be a database, file system, third-party APIs, IoT devices, you name it, that's fine. Now the thing is, even though you can manage to have a exception-free domain, those things on the right, they will throw tons of exceptions. And so what's the problem? Well, if an exception happens here, it will propagate until it meets a try-catch block, okay? And for me, that's a problem. Because if you have a try-catch block in your domain trying to deal with an error from there, well, your domain is supposed to be agnostic of a dependency. I should not see an entity framework exception in my domain. I shouldn't see anything about an API or this file system or anything like that. That's a problem. But what can you do? Well, what you can do is actually catch the exception right where it happens and decide, no, you will not propagate. My adapter will take care of it and will return, for example, a monad. And then you can write a domain that is fully exception-free. The driving adapters will throw exception as well, but domain is the most important part over there. If you manage to make it exception-free, it's going to be much easier for you to test it and much more predictable as well. So why did I want you to talk about all that today? Well, I wanted to bring you to show you a new tool for your developer toolbox. We all have our own toolbox where we put practices, frameworks, methodologies, yada, yada, yada. It's called experience, right? And the more tools you have in there, the more suited you are to answer to a problem with an adaptive solution, okay? So now, should you use monads or throw exceptions? I'm sorry, but nobody cares. You just lost 45 minutes, okay? Oops, sorry. The reason is, we work in a very complex field where the only absolute answer is it depends. Things will always depend on the context, the team, the customer, the budget, the whatever. There will always be something that will kind of force you to sometimes do a different decision. And here's a quote from Mark Seaman that I mentioned before. He put that more than 10 years ago in a blog post about command query separation, which is a very important OOP principle that you should try to apply most of the time, if not always. But Mark said, and Mark is always right, Mark said that sometimes he was like willing to break CQS. But when he was doing that, he realized he was making a trade-off because he knew the consequences, but he knew why he had to do it. You can take this quote and change it by when I decide to use exceptions or when I decide to use monads. Every decision you make is a trade-off. There is no silver bullet in our industry. Every option will have its own pros and cons. So what you need to do is first, don't listen blindly to a guy at a random conference, and I'm talking about me. What you need to do is experiment and forge your own ideas. So what I would like you to do after, I don't know, in a couple of weeks, is find one of those libraries, try it yourself, and see what's your opinion on it. Where do you struggle? Where is it better? Where is it worse? Because next time, when you will have the choice of just throwing an exception, maybe something else will be better. Maybe not. But at least it's your point of view that you can justify, that you can defend, and that you can also propagate to your team and other people. Okay? You need to be able to explain that. So if you're interested into digging more inside that topic, I wrote a series of blog posts about monads where I have more room to talk and go in the technical side of things and other things. So feel free to go there. There's also here the list of resources that I either used or that inspired me to write all of this, including a few books that I would really recommend. And now with the time for questions, I'm just going to pass the next slide. There is a QR code there where if you want to scan it, you get all the slides as a PDF and the text file with all the resources. It's free, it's all for you if you want it. So I hope you had a good time. I hope that you learned something. I had a great time. So thank you all for joining. And if you want to ask me questions, we do have some time. And otherwise, just catch me later. Thank you very much.
Thank you very much. Perfect. You planned time for questions. That is great because I'm kind of juggling here the questions in the breaks. But that's cool. So actually, I love these small citations you had on the bottom of the screen. Don't know whether somebody's laughing, so you notice them.
Don't trust everything.
Yeah, no, I don't. And you have to look at it then later on. So, is there anybody who has a comment or a question or something? Bless you. Oh yeah, I'm coming. Coming.
Hi, thanks for the talk.
No problem.
So I like this pattern, but I can see that it might be difficult adopting it in an existing code base. Do you have any experience or advice when it comes to that?
Oh yeah, it's never easy. I'm sorry if you expected like a magic answer that would solve everything. I don't. That thing is not, at first glance, people see that and say, oh, it's complex. No, it's not. You're just not used to it. It's like everything you learned. Now, where it's tricky if you want to integrate that in, let's say, a legacy code base, is this works well when you can handle the entire flow with it. One of the biggest mistakes I made when I started learning from that was trying to extract the value from the box too early. Like when you see my entire railway pattern, I was trying between every single step to extract the value. That was just not possible. It was kind of breaking things. So if you want to use that in a very isolated piece of the code, might get tricky when you want to extract the value rather than exceptions, because exceptions are like go-tos. They can send you to the other end of the code base just like that, which is kind of cheating. But yeah, what I would recommend is practice, because you don't want to end up in a space where, in the situation where you start working on it, it's cool, and you reach up a point where you don't know how to move forward, and you either keep going into a sunk cost fallacy fashion and you will lose time, or you go back and you lost time. It's exactly what I did. It's exactly how I learned. Don't do it. Okay, that's my recommendation.
Okay, thank you.
No problem.
Thank you very much. Looking around if there's any more hands, comments, criticism. I always ask, like on every talk, I think like I'm waiting for somebody who says,
I can take it.
says this is bullshit, but nobody dares to. Although I think it would be fun. So then I'm asking you, Fabian, did it match your expectations? Because you said this was the speech where you said you were curious about this topic.
Yeah, it did match. I really liked your, it depends. And just try it. Try to find a way to integrate it. See if it works.
It's very difficult to have like a one-size-fits-all approach when you come to this, because exceptions are anchored in people's mind. It's like, this is how I do things and I can't change. And you go to any school, this is how they teach how to do things. So you have to kind of keep an open mind. For me, I started working this way 4 or 5 years ago. It changed everything in the way in my perception to software engineering. So I'm using that all the time and everywhere. I don't throw a single exception, because you realize that actually most of the time you don't need it. You don't need an exception if it's just to catch it one level above. You can just return something. One thing that people can try if they want to go there step by step is at least to replace exception by the result pattern, which is very similar, except that you can't chain the things together. So it would be like using that and extracting it right after. So you would get plenty of if-else statements, because you have to deal with, well, what if it's a success, what if it's not? When you start looking like coding like this, your code is going to be very vertical. You won't have like a long horizontal indentation. I don't know if you're familiar with a code landscape, about the code that looks like a mountain, which is bad. In that case, it's just a line. And it's much, much easier to deal with, at least when you kind of are used to it, but that requires practice like anything else, you know.
Okay, I think actually this is always the expert answer. It depends, huh? This is that's just what Alex Turo said, like the rookie and then the expert, and then it's always again like, oh no, I don't know, make a change.
It's a very personal perspective.
Sure. But that's what we're here for, you know, changing
absolutely.
Experience and personal opinions, so that's great.
Never trust people who claim to have a definite answer.
That's true. Now I don't... sag jetzt nichts Falsches, Rabia. Okay, great. So then I'm coming... La prochaine fois, on va le faire complètement en français, n'est-ce pas?
Aucun problème.
Ouais. So, na, wir machen das nächste Mal das nicht komplett auf Französisch, den Vortrag. Das fände ich total schön, wenn wir das auch mal auf Französisch haben. Ich habe ja gehört, ne, ein paar Leute von euch hätten es auch vielleicht verstanden, oder? Ein bisschen. Thank you very much.
Thank you for having me.
For the effort of coming from France. We have lunch.